Welcome. Today, we are looking at sound waves. This is topic 10 in your SS1 physics series. This is the final topic in our SS1 physics series. This topic appears regularly in your examinations. Pay close attention. Let us begin. First, let me explain what sound is. Sound is a form of energy. It is produced by vibrating objects. Sound is a mechanical wave. This means it requires a medium to travel. Sound cannot travel through a vacuum. It travels through solids, liquids, and gases. Sound is a longitudinal wave. The particles of the medium vibrate parallel to the direction of wave travel. Sound waves consist of compressions and rarefactions. Compressions are regions of high pressure. Rarefactions are regions of low pressure. Understanding sound is essential for understanding wave phenomena. It is essential for many applications. Examples include music, communication, and medicine. Now let me explain the production of sound. Sound is produced by vibrating objects. The vibrations create disturbances in the medium. These disturbances travel as sound waves. The source of sound vibrates. Examples include a guitar string, a drumhead, and vocal cords. The vibrations are transmitted to the surrounding medium. The medium particles vibrate. This creates compressions and rarefactions. The sound wave travels through the medium. When the wave reaches the ear, it is detected. Sound is produced by any vibrating object. Understanding the production of sound is essential for understanding acoustics. Now let me explain the propagation of sound. Sound propagates through a medium. The medium particles vibrate. They transfer energy from one particle to the next. The sound wave travels through the medium. The speed of sound depends on the medium. Sound travels faster in solids than in liquids. Sound travels faster in liquids than in gases. The speed of sound also depends on temperature. Sound travels faster at higher temperatures. The speed of sound in air is approximately 330 meters per second. This is at room temperature. Understanding the propagation of sound is essential for understanding wave phenomena. Now let me explain the speed of sound. The speed of sound is the distance traveled per unit time. It depends on the medium and temperature. The formula for the speed of sound is v equals f times lambda. V is speed. F is frequency. Lambda is wavelength. The speed of sound in air is about 330 meters per second. In water, it is about 1,500 meters per second. In steel, it is about 5,000 meters per second. The speed of sound is important in many applications. It is used in sonar, echo, and music. Understanding the speed of sound is essential for solving wave problems. Now let me explain the characteristics of sound. Sound has several characteristics. The first characteristic is pitch. Pitch is determined by frequency. High-frequency sound has high pitch. Low-frequency sound has low pitch. The second characteristic is loudness. Loudness is determined by amplitude. High-amplitude sound is loud. Low-amplitude sound is soft. The third characteristic is quality. Quality is determined by the waveform. It distinguishes different sources of sound. For example, a piano and a guitar playing the same note sound different. This is because of quality. Understanding the characteristics of sound is essential for understanding music and acoustics. Now let me explain frequency and pitch. Frequency is the number of vibrations per second. It is measured in hertz. Pitch is the perceived frequency. High frequency corresponds to high pitch. Low frequency corresponds to low pitch. Humans can hear frequencies from about 20 Hz to 20,000 Hz. This is the audible range. Frequencies below 20 Hz are infrasonic. Frequencies above 20,000 Hz are ultrasonic. Ultrasonic sound is used in medicine and industry. Understanding frequency and pitch is essential for understanding sound. Now, let me explain amplitude and loudness. Amplitude is the maximum displacement of particles. It determines the loudness. Loudness is the perceived amplitude. High amplitude corresponds to loud sound. Low amplitude corresponds to soft sound. Loudness is measured in decibels. The decibel scale is logarithmic. An increase of 10 decibels corresponds to a tenfold increase in intensity. Understanding amplitude and loudness is essential for understanding sound. Now, let me explain quality and timbre. Quality is the characteristic that distinguishes different sounds. It is determined by the waveform. Timbre is another word for quality. It depends on the harmonics present. Harmonics are multiples of the fundamental frequency. Different instruments have different harmonics. This is why they sound different. Understanding quality and timbre is essential for understanding music and acoustics. Now let me explain reflection of sound. Sound reflects from surfaces. This is called echo. Echo is the reflection of sound. It occurs when sound bounces off a hard surface. The time between the original sound and the echo depends on distance. Echo is used in many applications. It is used in sonar and ultrasound. Echo is also used in music and architecture. Understanding reflection of sound is essential for understanding acoustics. Now, let me explain refraction of sound. Sound refracts when it travels through different media. Refraction is the bending of sound waves. It occurs when the speed of sound changes. This happens when temperature or density changes. Refraction is responsible for many phenomena. It is responsible for sound traveling further at night. Understanding refraction of sound is essential for understanding wave phenomena. Now let me explain diffraction of sound. Sound diffracts when it passes through an opening. Diffraction is the spreading of sound waves. It occurs when the wavelength is comparable to the size of the opening. Sound diffracts more than light. This is because sound has longer wavelengths. Diffraction is responsible for hearing around corners. Understanding diffraction of sound is essential for understanding wave phenomena. Now let me explain interference of sound. Sound interferes when waves overlap. Interference can be constructive or destructive. Constructive interference occurs when waves are in phase. The amplitude increases. Destructive interference occurs when waves are out of phase. The amplitude decreases. Interference is responsible for many phenomena. It is responsible for beats. Beats are periodic variations in loudness. Understanding interference of sound is essential for understanding wave phenomena. Now let me explain resonance. Resonance occurs when an object vibrates at its natural frequency. This happens when the driving frequency matches the natural frequency. The amplitude increases significantly. Resonance is responsible for many phenomena. It is responsible for the sound of musical instruments. It is responsible for the breaking of glass by sound. Understanding resonance is essential for understanding acoustics. Now, let me explain the applications of sound. Sound has many applications. In medicine, ultrasound is used for imaging. In industry, ultrasound is used for cleaning and testing. In music, sound is used for entertainment. In communication, sound is used for speech. In navigation, sonar is used for detecting objects. In architecture, acoustics is used for designing halls. Understanding the applications of sound is essential for many fields. Now, let me explain the difference between sound and light. Sound and light are both waves. However, they are different. Sound is a mechanical wave. Light is an electromagnetic wave. Sound requires a medium. Light does not require a medium. Sound travels slower than light. Sound travels at about 330 meters per second. Light travels at about 300 million meters per second. Sound is a longitudinal wave. Light is a transverse wave. Understanding the difference between sound and light is essential for understanding wave phenomena. Now, let me give you sample exam questions. Define sound. Sound is a form of energy produced by vibrating objects. State the characteristics of sound. The characteristics are pitch, loudness, and quality. Explain the difference between pitch and loudness. Pitch is determined by frequency. Loudness is determined by amplitude. State the speed of sound in air. The speed of sound in air is approximately 330 meters per second. Explain the reflection of sound. Reflection of sound is the bouncing of sound off a surface. This produces echo. Explain resonance. Resonance occurs when an object vibrates at its natural frequency. Let me summarize. Sound is a form of energy produced by vibrating objects. It is a mechanical wave. It requires a medium. The speed of sound depends on the medium and temperature. The characteristics of sound are pitch, loudness, and quality. Pitch is determined by frequency. Loudness is determined by amplitude. Quality is determined by the waveform. Sound reflects, refracts, diffracts, and interferes. Resonance occurs at natural frequencies. Sound has many applications. Understanding sound is essential for physics. This completes our SS1 physics series. Well done.